In this video, I'm going to explain you how to prove that integral 0 to pi by 2 log of 1 plus cos alpha cos x by cos x dx is equal to pi square minus 4 alpha square by 32. So this is an integral as a function of parameter where alpha here will be considered as a parameter. So now, as usual, let us take f of alpha x because we are taking alpha to be a parameter. So let us take f alpha x to be this one, log of 1 plus cos alpha cos x by cos x. And note down that this one has removable discontinuity only at this one, pi by 2. Because if we take the limit of x tends to pi by 2, log of this one, it will be of 0 by 0 form. So using the L'Hopital rule, differentiate the numerator separately and the denominator separately with respect to x. Then you see that it reduces to limit x tends to pi by 2, cos alpha by 1 plus cos alpha cos x. Now, if you place x by pi by 2, then this one will be, the denominator will not be 0. So it will come out as cos alpha. So that's why this one has removable discontinuity at that particular point only, x is equal to pi by 2. Also, now let us find out what is the differentiation of this f alpha x with respect to alpha. So if you differentiate that one partially with respect to alpha, f alpha x, I can denote this as equation 1. If you differentiate this equation 1 with respect to alpha, then that case you'll get 1 by 1 plus cos alpha cos x. Cos x will remain there in the denominator. Note here you have to differentiate with respect to alpha. So differentiation of 1 plus cos alpha cos x. Cos alpha will be minus sine alpha, and since we have this cos x, so it will be there. So cos x can be cancelled. It implies that f alpha of alpha x is equal to minus sine alpha divided by 1 plus cos alpha cos x. Now, here what we notice is that we see that f of alpha x and f suffix alpha x, that is partial derivatives of f alpha x with respect to x, are continuous functions of two variables, x and alpha, where alpha acts as a parameter in this case. In which domain? In the domain set of ordered pair alpha x, where x lies between 0 and pi by 2, and for all alpha. Okay. So now how to start this one? So to show that this given integral is equal to this one, let us take phi of alpha equal to this integral here. So we can take this one, let phi of alpha equal to integral 0 to pi by 2 log of 1 plus cos alpha cos x dx, whole thing divided by cos x. Name this as equation 2. If I take phi alpha to be this integral, then what is phi prime of alpha? Phi prime of alpha, since note down that f alpha x and f suffix alpha of alpha x are continuous function, therefore the derivation under the integral sign is valid. So this will be equal to integral 0 to pi by 2, the derivative of this one, f alpha of alpha x dx, that is del alpha of log of 1 plus cos alpha cos x by cos x. And this is equal to what? It will be 0 to pi by 2. Now you can see from here what is f suffix alpha alpha x. It is minus sine alpha by 1 plus cos alpha cos x. So you can substitute it there. So minus sign will be there. It will be sine alpha divided by 1 plus cos alpha cos x dx. Since sine alpha acts as a constant here, as the integral of this one is with respect to x, so you can take it outside the integral sign. So it will be minus sine alpha, then integral 0 to pi by 2 dx divided by, now here, like what we have done in the previous problem also, now what can be a c? We have cos x here. Then this one here, that is this one, can be written as cos square x by 2 plus sine square x by 2. As we know that cos square theta plus sine square theta is 1. Then plus cos alpha into, what is cos x? Cos x can be written as, we have a trigonometric relation as cos square x by 2 minus sine square x by 2. So this is equal to minus sine alpha integral 0 to pi by 2 dx, whole thing divided. You can combine this one, cos square x is common with this one. So you'll get it as 1 plus cos alpha into cos square x by 2 plus sine square x by 2 into 1 minus cos alpha. Now next, let us further simplify this one, this last integral. So it will be minus sine alpha integral 0 to pi by 2. Now if you divide both the numerator and denominator by cos square x by 2, then in the numerator you'll have it as dx divided by cos square x by 2. And if you divide the denominator also, then you'll see that cos square x by 2 will be cancelled. Then here you get sine square x by 2 upon cos square x by 2, which will give you tan square x by 2. So the numerator now becomes what? It will be 1 plus cos alpha only plus tan square x by 2 into 1 minus cos alpha. Now next you divide throughout by 1 minus cos alpha. Then this will be equal to minus sine alpha by 1 minus cos alpha. That is in the denominator, numerator also you divide by 1 minus cos alpha, and in the denominator also. So that term in the numerator will come down as the denominator here. So it will be 0 to pi by 2, and 1 by cos square x by 2 can be written as secant square x by 2. So the numerator becomes secant square x by 2 dx, whole thing divided by 1 plus cos alpha by 1 minus cos alpha plus tan square x by 2. So this one reduces to this form, and then this can be written as what? It will be equal to minus sine alpha by 1 minus cos alpha for the time being. Now what is the integral of this one? Du by a square plus u square. It is 1 by a tan inverse of u by a. So using that formula here, this one can be written as d of tan x by 2, and then 1 plus cos alpha by 1 minus cos alpha can be written out as 0 to pi by 2. Then if you differentiate this one, then half will come out. Differentiate tan x by 2, then half will come out from here. So you get 1 by 2 into okay, can write here this one as d of tan x by 2. Okay, if I differentiate this one, 2 will come out from here. So this one will not, actually I have to multiply by 2. This should be 2 here. Whole thing divided by square root of, I can write it as 1 plus cos alpha by 1 minus cos alpha the whole square, which will act as a square plus tan square x by 2. So as differentiation of tan x by 2 gives you secant square x by 2 into half. So that half and this 2 will be cancelled. So you will get the original one. So now this one can be written as what? Minus 2 sine alpha by 1 minus cos alpha. Then what is the, you can see, compare this integral with this one here. It is of form d of u. What is u here? It is tan x by 2. And what is a? It is square root of 1 plus cos alpha by square root of 1 minus cos alpha. So the integral of this now will become what? It will be into 1 by a. So it will be 1 by square root of 1 plus cos alpha by 1 minus cos alpha into tan inverse of u. Tan inverse of u, what is u? It is tan x by 2. So tan x by 2 upon a. A again here it is 1 plus cos alpha by 1 minus cos alpha. And the limit of integration here will be from 0 to pi by 2. So let us simplify this one. It gives you minus 2 sine alpha divided by 1 minus cos alpha into, now this being a constant which is independent of x, so you can take it outside that limit. So therefore you can write as 1 by, now 1 minus cos alpha will come to the numerator. So square root of 1 minus cos alpha divided by square root of 1 plus cos alpha. Then tan inverse of, substitute now, it will be tan x has to be replaced by pi by 2. So we have 2 again here. So we'll get tan pi by 4. Tan pi by 4 now divided by a. So this one will come to the numerator. It will be 1 minus cos alpha by 1 plus cos alpha. And if you substitute the lower limit, then tan of 0 will be 0. So that what part, the lower limit will give you 0 only. So now you can simplify this one. It gives you what? It will be minus 2 sine alpha divided, now if you cancel this one and this is under the square root sign, and this is 1 minus cos alpha. So therefore it will be under the square root sign now. 1 minus cos alpha into square root of 1 plus cos alpha will remain there. Tan inverse of, now what is tan of pi by 4? It is 1 into square root of 1 minus cos alpha by 1 plus cos alpha. Here you can write, since tan of pi by 4 is equal to 1. Now next, this can be written as minus 2 sine alpha divided by square root of 1 minus a into 1 minus a into 1 plus a. So it will be a square minus b, 1 minus a square. So it will be 1 minus cos square alpha tan inverse of, now this term inside the square root sign, the 1 minus cos alpha is same as 2 sine square x by 2, and 1 plus cos alpha is same as 2 cos square, sorry, this is alpha by 2. Now 2 can be cancelled. It gives you minus 2 sine alpha. Again here square root of 1 minus cos square alpha is same as sine square alpha. Under the square sign it will give you sine alpha. Then tan inverse of, here it will be square root of sine square alpha by 2 by cos square alpha by 2 will be tan square alpha by 2. And sine alpha can be cancelled. It is minus 2 tan inverse of square root of tan square root of tan square alpha by 2 will give you tan alpha by 2. So now let us see, further simplify it. It will be minus 2 into alpha by 2. Why? Because since tan inverse of tan theta, this is equal to theta. So 2 get cancelled, it is equal to minus alpha. So we have got that one as minus alpha. Now next, after knowing the value of this one, so what is this phi prime of alpha now? Phi prime of alpha, after evaluating that one, we finally got it as minus of alpha. Now integrating this one, this last integral, because this is phi prime of alpha, integrating it with respect to alpha. Integrating with respect to alpha, we have integral of phi prime of alpha will be phi prime of alpha. That is, the left hand side will be phi of alpha, and integral of alpha minus alpha will be minus alpha square by 2 plus some constant term, since this is the case of indefinite integral. So now we have to evaluate this value of c here. So note that let us name this one as equation 2. Note that in this case, when alpha is equal to pi by 2. So if I'm not mistaken, we have mentioned that one, equation 1, this one, or not the equation 1, I should have mentioned that one, or equation 2, we already have equation 2. Phi of alpha is this one. If I replace alpha by pi by 2, then what is phi of pi by 2 here? It is 1 plus cos pi by 2, that will be 0. So log of 1 here will be 0 by cos x, so it will exist, so that means phi of pi by 2 will be 0. Here, why I'm not taking the initial value 0, because if I take a 0, then in that case it will be 1 plus log of 1 plus cos x by cos x, so which is under the integral sign, and it is impossible for us to find out that constant c. So let us evaluate that constant c by taking alpha to be pi by 2, because this function fx alpha is continuous for all values of alpha. So for a particular value of alpha is equal to pi by 2 also, it exists. So in this case, note this case when alpha is equal to pi by 2, let me name this one as equation 3, this one. From equation 2 you can mention, this will implies that phi of pi by 2 is equal to integral 0 to pi by 2 log of 1 plus cos alpha, so it will be cos of pi by 2 cos x divided by cos x dx. Now cos of pi by 2 is 0. So you will get log of 1 will be 0. So 0 by cos x will be 0 only. So finally it gives you phi of pi by 2 is equal to 0. Since you can write cos of pi by 2 is equal to 0, implies that log of 1 plus cos pi by 2 cos x divided by cos x is equal to 0 by cos x, which is equal to 0. So finally cos pi by 2 is equal to 0, and then let us see from that equation 3. So replace the value of alpha by pi by 2, then it will be phi of pi by 2 will be 0, and this will be minus pi by 2. So putting alpha is equal to pi by 2 in 3 and phi of pi by 2 is equal to 0 in 3, we have 0 is equal to minus alpha square. It is minus alpha square by 2. So it will be minus pi by 2 the whole square divided by 2 plus c, which implies that c is equal to pi square by 8. You will have here the value of c is equal to pi square by 8. Now let us see substituting. Putting c is equal to pi square by 8 in equation 3, we finally have phi of alpha. phi of alpha is equal to minus alpha square by 2. I think we have it as alpha square by 2 minus alpha square by 2 plus c. What is c? It is pi square by 8. Take the LCM, it gives you phi of alpha is equal to minus 4 alpha square plus pi square divided by 8, which implies that phi of alpha, you can simplify, you can write it be pi square minus 4 alpha square by 8. Please correct in the statement of this theorem I have mentioned, it should be not 32, it should be 8. Okay, so prove that integral 0 to pi by 2 log of 1 plus cos alpha cos x by cos x dx is equal to pi square minus 4 alpha square by 8. So as usual, take the value of f of alpha x to be this 1 log of 1 plus cos alpha cos x by cos x. Then differentiate this one with respect to alpha, then you get the value of f suffix alpha of alpha x. Now next step, what you need to do, you denote this integral phi of alpha to be integral 0 to pi by 2 log of 1 plus cos alpha cos x by cos x. And then by using the theorem that we have proved in the integral as function of parameter, if the function f alpha x and f suffix alpha x are continuous, then in that case the differentiation under the integral sign will be valid. So if phi alpha is this one, then phi prime of alpha will be the same integral, but here you have to differentiate this one with respect to alpha under the integral sign. So on simplifying this one, you'll see that you'll get the value of phi prime of alpha. So to get back phi of alpha, you have to integrate this one now with respect to alpha. So on integrating it with respect to alpha, you'll get phi alpha is minus alpha square by 2 plus c. Let us find out the value of this constant c. Since the function f alpha x is continuous for all x, therefore let us take a particle value of continuous for all values of alpha. So therefore let us take it for alpha is equal to pi by 2. Because if I take it 0, then in that case we cannot evaluate the constant c, because you'll get 1 plus cos of 0 is 1. So it will be log of 1 plus cos x by cos x, integral of that one. So it will be a lengthy process for us to evaluate that c. But now if I take this particular value of alpha to be pi by 2, then in that case this cos of pi by 2 here, that is alpha is equal to pi by 2, will be 0. Then it will become log of 1. Log of 1 will be 0. So phi of pi by 2 will become 0, and that one will give you the value of that constant c. So by taking the particular value of alpha is equal to pi by 2, then we are able to get the value of this constant c, and then put back the value of that c in the equation 3, then you'll get phi of alpha. So phi of alpha become pi square minus 4 alpha square by 8. But what is phi of alpha? In the beginning, I've taken as integral 0 to pi by 2 log of 1 plus cos alpha cos x, integral 0 to pi by 2 log of 1 plus cos alpha cos x divided by cos of alpha is equal to pi square minus 4 alpha square divided by 8. Hope it is clear now.